There we go. There you go.
Yeah. Okay. Alrighty, start over on the relays that you can see the arrows. These relays, the peanut relays, we add to the top of the evap coil on the electrical connection side. And you can also see that there's the terminal board that's on the end there. So that's the first step that we do. You'll see that I've got, if you can read it up there, that I've got them labeled. And I'll go to the next screen here. You'll see that I have them labeled in this order as the liquid line solenoid valve on the left, the fan on the middle, and the heater on the right. It isn't necessarily in this order. It doesn't have to be in this order. It's just how that I've set it up on the board. On this particular picture, you'll see that we have brought in the low voltage wiring and have hooked up to terminals 1 and 3 on each of the peanut relays. We are using the black as the common. The 24-volt power source is located at the EMS panel or the SSDI panel in the new stores. Starting in about, I believe it's April of this year, we went straight to a 24-volt control system away from the line voltage that we were putting through the wire. So in the older stores with EMS installation, be aware that you do have either the neutral being switched or you do have one of the 208 legs being switched. In this particular picture, as you take a look, we have the red wire will always go to the heater relay. The green wire will always go to the fan relay, and the white wire will always go to the liquid line solenoid valve. Right above each of the relays, you'll see that I put that number 4 to number 5 is normally closed. Number 4 is the line side of that relay. That's where your voltage or your power that you are switching goes into. The load side is either 2 or 5. We will always wire these up to fail-safe and cooling mode. So on the liquid line solenoid valve and on the fan, we will wire from 4 to 5. The number 5 terminal going to the fan or to the liquid line solenoid valve itself. On the heater, we don't want that to fail safe on, so we wire the load side to number 2. That is the normally open contact. The next step that we take at this point is we wire in the 208 power. Now this is the wiring for the beer cave and the kitchen freezers. We bring in the power from the condenser. We take it off the time clock and then move the wires down to the line side of the contactor, bringing the 208 volts down, and we attach that on the terminals that are labeled H1 from the factory. You'll see that I put L1 and L2 there. The L1 is going to be the one side of your fixture control, and L2 will be the other side to complete the circuit. You'll see that the red wire that we've taken off of L2 is daisy chained to number 4 on each of the relays. The arrows that you're seeing on this particular photo are showing that we are taking the L1 or one side of the leg directly to the solenoid valve. We're also taking it to one side of the fan, and of course the heaters are already attached to H1. This photo is showing that I took a Y wire that I had here that goes up to complete the circuit for the solenoid valve, and that is coming off the terminal number 5. In the middle one, you'll see that that particular wire off of number 5, goes down to F2, which is the other side of the fan motor to complete that circuit. And on the orange wire is on number 2, is going down to H2, which is the other side of the heaters. And that provides that our relays are now switching each of those components on and off. This particular picture is showing the additional harness for the beer cave. In the beer cave, we usually have 2 coils. So we'll take 3 wires from what we call the master coil. The black wire is actually going to H1. That will supply all the power to the fan and the heaters in the slave coil. You will also find that we're taking a wire from H2. In this particular picture, it's a red wire. That will go to H2 in the slave coil to complete the circuit for the heaters. And in this picture, we also have a brown wire that we are using that is attached to F2, which will also take power to the fans, and that will allow us to run the fan. So everything is being run from the master coil. One difference in this that I did not put in this picture is we do have a double pole single throw relay that we are using. One heater circuit for the master coil will go through one side of that particular relay, and then the slave will be on the other, and that's due to the amount of amperage that has been going through these relays. So that would be the only difference from this. So is there any questions or anything that you guys would like me to go back over on this? Okay, we'll go ahead and move on then. Okay, this is the beverage in the kitchen coolers. This particular one is showing the existing T-stack control.
Again.
Pardon?
You need to adjust the view again. We've only got a quarter of the view. Oh, shoot, I'm sorry. It's my screen.
Oh, I'm feeling better now. So, okay, the T-stat is usually mounted up on the side of the evap coil. You'll see that the 2 wires are coming in. They are distributed out to the fan motor and the coil. All we do in this particular cutover is we simply add a relay. We bring our wire in from the control panel 508 board with our 24-volt control, attach it to 1 and 3 on the coil, and then we simply just remove the 2 wires from the thermostat. We put a couple of female spades on them and connect that to 4 and 5 are normally closed so that we fell in refrigeration mode. This is one of the easier and simpler transformations that we got. So does anybody got a question on this one? We're going to go on then to the condiment bar. Basically, it's the same as the kitchen and the freezer. You'll see here that the newer condiment rails or bars have the Danfoss Dixell style controller. Usually you'll see that it has 3 wires. You've got a brown wire that is the load side to the compressor. The black wire is the power in. And the white wire is just additional to supply power to the Danfoss controller to operate. All we're doing in this particular instance is we're eliminating the white or the neutral wire, and we're simply just taking the black power wire, putting it on 4 for the line in, and taking our brown wire, which is the load side to the compressor, and putting it on 5. There again, making it a fell in refrigeration mode. Also in this one, we are removing the temperature probe that goes up to the well and putting our own slab temperature probe in its position. Does anybody have anything at this point they'd like to go over? Okay. This is the new case controller that we are now implementing in the EMS stores. When we have issues with the beacon control, it's the quick response controller, either with the Corel valve or with the quick response controller. We are now going back in and replacing if it needs to be replaced because of failure on either one of the valves. So we wanted to show this, how this is actually going to set up. We're going to be putting these up right above the box near the evap coil, and it'll show that we're taking power. The case controller will actually accept anything from 115 to 240, and there's nothing that we need to do to specify what voltage. It will automatically recognize the voltage and go from there. In the case of the beer cave and the freezer, you'll see that there will be an additional defrost heater contactor installed to run the heaters in each of the coils. That's due to the amount of amperage that needs to go through the relay itself, and the case controller won't handle that type of amperage. We also can control the fans through that. You'll see the green plug to the left of the orange wire that we'll be able to turn the fans on and off. We do have a suction or a 200-pound transducer that is shown here. That may or may not be at the coil. We can, through the program, use the suction transducer that's already mounted up at the condenser for this purpose. You've got a blue temperature control on the head of the sensor there. It actually has a concave or a pipe fitting on it that makes it easy to attach it to the refrigeration pipe, and this is going to be located at the outlet of the evaporator coil so that we can see the temperature of the coil itself. And the green lead is a space temperature, but it will be mounted on the return air grill so that we can see what the return air temperature is. The orange lead will only be used if it is a electric assist defrost, so that we can see what the temperature is during defrost for termination purposes. We do have other auxiliary inputs that we can use there, but on the far right you'll see the electronic expansion valve connection there, and these are all color coded. This will be something that we could easily send the equipment out to the tech, and just by following the coloring codes and placing the sensors where they need to be placed, you guys would be able to install this for us. All we'd have to do here locally is be able to drop a program into each of the stores to be able to operate these controllers. There is an orange plug like on all the other microthermal boards. You can see that in about the middle of the board itself, to the left of the transducer wiring. That is our network wiring, so there would be an additional wire there putting it into the network, thus letting us be able to communicate with the board and be able to see the operation of it. This next picture that we put in gives you an idea of how this case controller is functioning there, and where the different sensors and the components are needed to be placed so that it can accurately make the system work the way it's designed. Should have brought a glass of water. So at this point, is there any questions about this or anything that you would like to?
So are the orange sensors getting used in just specific cases now?
Right, the orange sensor has always been for defrost,
Yeah.
for us to use for defrost termination temperatures, and so that's why they've only been added to the beer cave and the right. They're the only ones that have electric assist or defrost to add heat to the coil to get it to go. Your other coils are just an air defrost, and we have not been adding defrost termination to those. We've been allowing them to go on a timed defrost. Gee, thanks.
So those blue ones are just going to go on the coils. Orange one in that hole.
Right. The difference between the blue and the orange basically is that it's designed so they can easily go onto a pipe and be strapped on. Right. Other than that, all of these temperature sensors are 10,000 ohm. So they're the exact same sensor. They just are a little bit different on the head for different applications.
Cool.
Is there any other questions? Anything else you guys would like to go back to and discuss? Okay. Okay, that's the end of the slideshow that we've got here now. We'll go ahead and end this unless anybody has anything they want to add or go forward with. Real quiet. Okay. All right, thanks guys. We'll talk to you later then.